Yes, I started, but I forgot to turn on the mic. Okay. So now I hope that I am audible clearly. Okay. So yeah, good afternoon, and we are joining back for the lecture session, for the theory session right now. Okay. So in our last session, in our previous year lecture session yesterday, we started with the topic of kinematics of particle, and in that we discussed and we established the relation for the case of uh, rectilinear motion, right? And we solved some problems regarding variable acceleration. Okay, so we'll be continuing the discussion today. We'll be taking a couple more of problems. Okay, about variable acceleration, and then we'll be proceeding to curvilinear motion. Okay. So at the end of today's lecture, okay, so this part which was there, okay, so we have already covered the theory part which was there, to establish the relation between displacement, velocity, and acceleration for a particle. And because we are specifically interested in variable acceleration motion. Okay, so we are not considering the case of uniform acceleration motion, because uniform acceleration motion it is already covered. So we are more interested in covering about the variable acceleration motion. Okay, so today, at the end of today's session, okay, so I should be able to establish the relation between displacement, velocity, and acceleration of a particle for any scenario, or for any case scenario in the case of variable acceleration motion. Okay, so that is going to be our lesson outcome today. Okay, so the first question is, this is actually an interesting question. Okay. The motion of a particle which is defined by the relation, okay, x equal to 3t cube minus 18 into t square plus 26t plus 8. X is the position expressed in meters and t is measured in seconds. I am supposed to determine the time when the total velocity is 0, and secondly, I am supposed to find out the position and the total distance traveled when the acceleration it becomes 0. Okay, so these are two cases, separate cases. Okay, so, and we'll be taking both of them, and we'll try to solve both of them. Okay, and let's see what happens. Okay. This is actually one of the recent questions, okay, in the university examination. So you can also keep note of that. So you can keep this question as a recent important question, okay. So to start with my relation, which is there, okay. My relation, it was 3 into t cube, right? My relation of x, which is there, that is 3t cube. Just a minute. It is.
Sir, can you just again show the question?
Okay. Okay, so this is my relation for displacement. Okay. So next, what I'm supposed to make the relation for velocity, right? So as we have discussed, okay, in the previous lecture, okay, so velocity, which is the instantaneous. When I'm talking about velocity, okay, so it can be either the average velocity or the instantaneous velocity. Okay, but as per our general expression, so we'll be talking about the instantaneous velocity at that particular instant. Okay, at that particular second. So v, it is given by dx by dt. Okay, so v equal to dx by dt, so that is equal to d by dt of 3t square minus 18 3t cube minus 18t square plus 26t plus 8, which comes out to be, can you tell me the expression?
So 60 square, 90 square
Hmm.
minus
Hmm.
36t,
Hmm.
26.
So this is my equation for velocity. Okay, so let me mark this as equation 1. My equation for velocity is equation 2. And then subsequently, let me also take the equation for acceleration. The acceleration is given by dv by dt, okay, the instantaneous acceleration which is there, it is given by dv by dt, or also given by d square x divided by dt square, right? That is equal to d by dt of 9t square minus 36t plus 26. The expression comes out to be as 18t
18T
minus
minus
36.
36.
So now I have formulated the relations, okay, the relations for velocity, acceleration, and displacement. Now in this case, if I am actually throwing some light on the acceleration, you can, as you can see the expression, it is 18t minus 36. So the acceleration is there. What type of acceleration it is? The acceleration, it is linear, it is
Linear.
parabolic, it is uniform acceleration. What type of acceleration is it?
Sir, it
It's
is
linear
linear.
acceleration, right? It is called as linear acceleration, right? The
Yes, sir.
the relation between A is, which is there, A is directly proportional to T, right?
Yes, sir.
So in the when, so this will actually give me some, so this will give me some light to see when I am actually going to talk about motion curves. When I'll be discussing about motion curves, then this thing, it is important. So when the acceleration, I want you to note here, I want you to see one thing. When the acceleration, which is there, acceleration is directly proportional to t, then what happens? My velocity, which is there, it is directly proportional to what quantity? A velocity is directly proportional to t square, right?
Yes,
Velocity is
sir.
directly proportional to t square. And what about the displacement? It is directly proportional to t cube.
PQ.
So when I want to plot this motion in the form of a graph, then what happens? Acceleration is directly proportional to t. So what happens? The
Straight
graph that
line.
will be plotting between acceleration and time. So it will
Uh,
be, what? It
at
will
an
be a
angle of
straight
straight
line.
line.
It will
Yes, sir.
be a straight line with either positive slope or negative slope, right?
Yes, sir.
My acceleration time graph is that can be either like this or like this, whichever. So if this is this case, then it will be a case with acceleration time here when it is having positive acceleration, or when my particle, it is undergoing deceleration, that means reducing acceleration. Okay, so when the velocity, the acceleration is causing it to reduce its velocity, then it will be having a negative slope. What about the velocity time graph? What will be the shape of the graph? Velocity time,
Parabolic.
it is a parabolic curve. Yes. So when the acceleration and time, it is linear, okay, so what happens? My velocity time curve which is there, okay, so that will be parabolic. Then if it is if the my acceleration is reducing, then what happens? What about my
Mm,
velocity time graph? Okay, so that is a relation. Okay, so this, if this is my linear, if the acceleration is linearly varying with respect to velocity, with respect to time, then my velocity will be varying parabolically, right? It will be a square relation, and the displacement which is there, it will be a cubic relation. X is directly proportional to t cube. This actually forms the one of the why I am discussing this right now. This actually is one of the cases which I should be remembering when I am actually studying about motion curve. वहां पे हमें इसी को डिस्कस करना है. हम हमारे पास वहां पे ऐसे मल्टीपल केसेस रहेंगे where suppose my acceleration is there, okay, so when I'm talking about motion course, firstly what happens, firstly I have acceleration equal to 0 will be there. When the acceleration is 0, then I'll be having what? My velocity, it will be uniform velocity, right? The velocity, it will be uniform. Then what about the displacement? The displacement, it will be continuously increasing, right? Either it can be continuously increasing, or the displacement can be continuously decreasing, whichever. Second, the acceleration, it is a constant value. So when the acceleration is a constant value, then my velocity which is there, velocity, it will be linear, and my displacement, it will be parabolic. A equal to 0, then V equal to C, then here X is directly proportional to T. Here acceleration is constant, V is directly proportional to T, and X is directly proportional to Mhm. Then X is here. x is directly proportional to t square. ये एक केस हो गया, ये दूसरा केस है, ये तीसरा केस है, acceleration directly proportional to time. So these are actually what the same things that we'll be discussing in the case of motion curves. Okay, so this was actually giving me some idea. Okay, so उसके लिए हमने वो कभी ले लिया because we were talking about the expression, so हमने वो directly अभी दिखा लिया. So I was able to show you that example. Okay, now when I want to show, okay, now I let me go to my condition. What is my condition given? I'm supposed to find out the time when the total velocity is zero. So my first case, when v equal to zero, I am supposed to find out the time. So what is the expression for the velocity? The expression for velocity is 9t square minus 36t plus 26, right? So implies 9t square minus 36t plus 26 equal to 0. Or implies, can you give me the value of time that you get? What is the value of time? Am I audible?
Yes, sir. ये टाइम आपको इतना टाइम क्यों लग रहा है? 0.9459 seconds, or maybe I can also call it say that as 0.95 seconds. So this was the first case. Okay, so when for this particular condition, which is that when my total velocity is zero, okay, so then my displacement, which is there, the displacement I'll have to find out. Okay, and I'm supposed to find out the total velocity when it's zero, the time which is that comes out to be as 0.95 seconds. So next case, which is that I am supposed to find out the position and the acceleration. Okay, so when acceleration becomes equal to zero, I am supposed to find time, and I am supposed to find out the, sorry, not the velocity, I am supposed to find out the displacement, or more than displacement, I am supposed to find out the distance travel, right? So what can you now here? Can you tell me what is the difference between x and s? Hmm? X,
What is x and what is s?
X is a distance and S is a displacement. X is a position and S is a displacement.
X position, okay. S is position or displacement.
S is a displacement.
Hmm. S is distance. ठीक है? S is scalar, X is vector. ठीक है?
Okay.
So now for this, so when I'm to evaluate for acceleration, so what expression I'll be taking? I'll be taking the expression for acceleration, A equal to 18t minus 36. Number 3 implies 18t minus 36 equal to 0. It implies what happens? It is very simple and straight at t equal to 2 seconds. Now I have found out, I am able to find that, okay, when the acceleration is 0, at the time t equal to 2 seconds, then acceleration becomes equal to 0 for this particular motion. Now, firstly, I have time, which is an independent quantity. Then I have my x, which is there. Okay, the displacement at that particular time, right? So when initially when time equal to t equal to 0 seconds, what happens? My x, which is there, that is 3t cube minus 18t square plus 26t plus 8. So when t equal to 0, I have one value remaining, right? So when t equal to 0, then I'll be getting my initial displacement x as 8 meters. Okay. Next, when the time is now the next case which is that I will be taking here. I have three instances of time, right? So firstly, when I have at the start when t equal to 0. Secondly, at t equal to 0.95, and thirdly at t equal to 2 seconds. The second case when I'm considering, okay, so when t equal to 0.95 seconds, okay, so then at that time what happens? What is my displacement? Can you give me the displacement at that point? Okay, so at for t equal to 0.95 seconds, okay, so I'm getting my displacement as 19.027 meters. Next, when I'm considering the time when at t equal to 2 seconds, okay, so at that time I'm getting my displacement x as 12 meters. So now, okay, so if I want to plot that motion, okay, so since we are considering the motion about a straight line, okay, so let me plot it. So here, which is there, okay. So initially, this is at x equal to 0. Okay. Now, when t equal to 0, what happened? What I found out? When t was equal to 0, I found out that my displacement it was 8 meters, right? So here I have x equal to 8, t equal to 0, x equal to 8. Then the next case, which is there, t equal to 0.95 seconds and x equal to 19 meters. This is okay, fine. So here x equal to 19 meters. Then after that, when the time it is again increasing, time which is the time does not reduce, right? So when the time is again increasing, then I'm finding out that my displacement it is reducing to 12 meters, x equal to 12. So then when I want you to read the question again. Okay. In the question, what I'm supposed to find out? I'm not supposed to find out the displacement. I'm supposed to find out the total distance which is traveled, right? if I was if I was talking about the total displacement of the particle, then what would it have been? Can you tell me? If I was talking about the total displacement of the particle, then what should I be? What would have been the displacement?
8 plus 19.027 minus 12.
The initial position minus the final position minus the initial position. What is the final position? 12. What is the
Yes,
initial
sir.
position at t equal to 0? What is the initial position? 8. So what will
8,
be my displacement? 12
12
minus
minus
8, 4. 12 minus 8, 4, right? Because all values are positive. Okay, so final minus, if you are taking final minus initial, okay, so then I'll be getting my displacement as 4 meters. But is that the total distance which is traveled?
no, sir.
That is not same as the total distance traveled, right? Because my particle which is there, okay, so my particle has traveled from x equal to 8 meters to x equal to 19.027 meters and then back to 12 meters. So what is the distance, that total distance which is traveled? What is it?
39.027.
From here, okay, so from x equal to 8 to 9, x equal to 19, and then from x equal to 19 to x equal to 12. That will be my total distance traveled. Understand the difference? Okay, that's why that's why actually I marked x also, here I marked s also. X is my displacement. So here, what is the total displacement of the particle at the end of 2 seconds? Understand clearly. At initially when t equal to 0, my x is 8 meters. Then at the end of 2 seconds, what is the total final position of the particle? That is at x equal to 12 meters. So what is my displacement? It has been displaced from 8 to 12 meters. So the displacement of the particle at the end of 2 seconds, that is 4 meters. Okay. Do you agree with it?
Yes, sir.
That is my displacement. But is that my total distance that the particle has traveled? My particle has traveled from 8 meters to 19 meters and then back to 12 meters, right? So my total distance it will be x equal to 19 minus x equal to 8 plus x equal to 19 minus x equal to 12. So that will be my expression for the total distance traveled. So my total distance traveled equal to 19.027 minus 8 plus 19.027 minus 12, and that much meters. And what is the final position? Position of the particle after 2 seconds. That is 12 meters, right? So that is my final position, and this is my total distance. Kim, can you give me the value then?
18.05.
Value, total distance,
18.054.
18.054 meters. Now I want you to note the distance difference between my distance travel and my and the position, final position of the particle. So after 2 seconds, my particle position is that is at 12 meters. And what is the total distance traveled in that duration? The total distance traveled in that duration is this 18.054 meters. Okay. Any question? Okay. So now we'll take one more question. Okay. So here I have again something similar to that. Okay, but slightly different. Now each of this I am okay in the small, actually in the whatever the smaller time limit, time duration that we are having. Okay, what I'm trying is that I'm trying to give you as much of the variety of numericals as possible. So please kindly pay attention here. Okay, so now the next case is that the acceleration of a particle along a straight line, which is represented by a equal to 30 minus 4.5 into x square. The motion, it is starting with 0 initial velocity at x equal to 0. So I have a equal to 30 minus 4.5 x square. Firstly, then I have v equal to 0 when x equal to 0. I'm supposed to find out the velocity when x equal to 3 meters, then the position when the velocity is again 0, and then the position when the velocity is maximum. Okay. So now we'll take all the three cases one by one. But before that, okay, so let me write it down. A equal to 30 minus 4.5 x square, and I have v equal to 0 when x equal to 0. Okay. So now in this case, I am all the cases where are there in this particular expression. Okay. So it is given acceleration in terms of displacement. Firstly, secondly, anywhere do I have time? Do I have time coming anywhere? I do not have the expression for time, right? तो मुझे कौन सा expression use करना है यहाँ पे? Acceleration equal to
dv by dx.
v into dv by dx, yes, equal to 30 minus 4.5 x square. So implies ये मेरा first expression हो गया. I'll be requiring this. Okay, at some point I'll be requiring this. Second, now acceleration equal to v dv by dx equal to 30 minus 4.5 x square. So I have v dv equal to 30 minus 4.5 x square, okay, into dx. So implies integral v dv equal to integral 30 minus 4.5 x square dx. Integral v dv,
V square by
So implies v square divided by 2 equal to integral 30 dx,
30x minus
30x minus,
4.5 x cube by 3.
correct, right? 4.5
Yeah.
into x cube divided by 3. So that will be 1.5 into x cube.
C equals to 0.
Now, this case which is there, okay, so now I have to apply my initial condition v equal to 0 when x equal to 0. V equal to 0 when x equal to 0, and that is given, right? So implies I'll be getting it as c equal to 0, or implies v square by 2 equal to 30x minus 1.5 x cube, or implies v which is there I can get it as under the root of 60x minus 3x cube. Right? मैं कोई भी expression लिखूं, okay? Because I was supposed to find out the velocity, right? मुझे यहाँ पे I'm supposed to find out the velocity when x equal to 3 meters. So fine. हमें वो expression काम आएगा. Now first case, when x equal to 3 meters, right? So v equal to under the root 60 into 3 minus 3 into 3 cube. अब मुझे velocity बताओ.
9.949.
9.9,
95.
9.9498, okay, or equivalent to 9.95 meters per second. Okay, fine. Now second case which was there, okay, so in my second case what I have to find out? I have to find out the displacement when the velocity is equal to 0. Okay, the second case when v equal to 0 implies what happens, this expression which is there. So in this expression, my LHS which is there, that becomes equal to 0, right? So I am left with 30x minus 1.5 into x square. 30x minus 1.5 into x square x cube equal to 0. So what will be the value for x then? Now 1x which is there, 1x it will be, I can take common 1.5x I can take common outside, right? So 1.5x multiplied by 20 minus x square. So it will be under the root of 20. Okay, so plus or minus under the root of 20. So that comes out to be as x equal to 4.47 meters, which is that. Now here it can also be minus 4.47 meters, right? But here, okay. So since we had considered the positive displacement earlier, okay. So in my first case, what it was given as x equal to 3 meters. So I am considering positive displacement. So that's why I am taking only my positive value. Okay. So this is my second case when my velocity equal to 0, then my LHS RHS is there, that entirely becomes equal to 0, and hence I will be getting value of x as 4.47. So in this expression, what happens in this particular expression? The value of x which is there, x can be 0, x can be 4.47, comma x can be minus 4.47. All three values are true, but which value am I taking? X equal to 0, it is already taken here, right? X equal to 0 condition already taken. Then I have plus 4.47 or minus 4.47. So between them, since we had considered the displacement, initial displacement as x equal to 3 meters, right? So my first case we took as positive. So the next case also I am taking as positive. Okay. But just because of that, it is, if I am taking as the minus 4.47 meters also, that is not wrong. But I'm giving you the logic also, that why I'm taking plus 4.47. Okay. Then the third case which
So
is that,
because first one is also positive, that's the only reason, no?
that see, the x equal to 0 is neither positive nor negative, right? So
Yeah.
this is
Yes,
0 is
sir.
my initial condition. Next, the velocity when I'm finding out what velocity, the velocity when I'm finding out at x equal to 3. So I'm taking x equal to plus 3, right?
So just
Okay,
because
sir,
of
I
that,
got
I
it.
am taking it as next as 4.47. So the
Yes,
motion is
sir.
continuing in that same direction.
Yes, sir.
Just assuming that. If not, the other case is also possible. It is not that it is not possible. Okay.
Yes, sir.
Okay. Then the third case, which is there, when I have to find out the position when the velocity it is maximum. Now I have a question. Now in this any of these cases, okay. So am I given the value of V max? Okay. Am I given the value of V max then?
No, sir.
No, sir.
So how do I know, or what? How will I evaluate that third condition?
So when acceleration will be high.
Any case, let me take any case. Okay. So what happens when I'm reaching? Suppose I'm reaching the maximum velocity which is there. Then at that point, what happens? Will the body increase its velocity further?
No, sir. Acceleration become constant.
The acceleration becomes constant or acceleration becomes zero.
Yes, sir.
Whenever v equal to v max, right? When if I am having v equal to v max, then what do I say? I say dv by dt equal to zero, right? The rate of change of velocity is zero. Correct?
Yes, sir.
Something that we have studied, we have seen somewhere, कहीं तो भी पढ़ा है लेकिन भूल गए, वैसे वो वैसे आपको लगा है, आपको कहीं पे एक परछाई जा रही है स्कूल में, कहीं पे तो हमने ऐसे देखा है कभी कभी मुझे पोजीशन जब when my velocity is maximum, then my dv by dt which is there, the rate of change of velocity, that becomes equal to zero. So dv by dt is nothing but acceleration. Acceleration becomes equal to zero. So implies, what was my expression then here? 30 minus 4.5 x square. So 30 minus 4.5 x square. So when v equal to v max, so implies a equal to 0. Implies 30 minus 4.5 x square equal to 0. So implies you can give the value for x. Will you give me the value for x? What is it? And along with actually finding out the value of x, I can also find out the value for the maximum velocity. Okay, just for the sake of information. So can you do that quickly and tell me?
Point 387.
Hmm?
0.387.
Hmm. 0.387. No, it's wrong.
So it's 4.5, na?
Yes.
2.58.
Sir, 2.582.
2.58.
2.5819 meters. आपको पॉइंट कहाँ से आ गया? 30 माइनस 4.5 इंटू एक्स स्क्वायर है, 45 नहीं है. आपको यहाँ पे भी लिखा है, देखो सेम एक्सप्रेशन ऊपर में यहाँ पे लिखा है, ये 4 स्टेप में लिखा है. And what is the value of the Vmax? मेरा क्वेश्चन यहाँ पे, मेरा जो क्वेश्चन में जो पूछा था पोजीशन व्हेन, वो यहाँ पे खत्म हो गया मेरा. बट Vmax, just for information, what is the maximum velocity that it attains? वो मुझे देखना है ना, मैक्सिमम वेलोसिटी दैट इट अटेन्स. हेलो.
Yes, sir.
हाँ हाँ हाँ, अरे डाउट हो जाता है मैं मीटिंग में हूँ कि नहीं हूँ करके. तो अंडर द रूट ऑफ 60 इंटू 2.5819 माइनस 1.5 इंटू 2.5819 क्यू. या माइनस 1.5 नहीं, -3 इंटू हो जाएगा. So I'm getting Vmax as 10.163 meters per second. Okay, is that correct?
Sir.
Yes, go ahead.
No, sir, answer is correct. I was saying that.
Okay, fine. Okay. So with this, we'll conclude the topic about the rectilinear motion. Okay. If you have any questions about rectilinear motion, okay, हमने कल डिस्कस किया, अभी आज भी डिस्कस किया है. Okay. So if you have any questions, you can ask them now about any of the numericals that we have solved. Okay. So आपको question है तो आप पूछ सकते हो.
सर.
हाँ.
सर वो जो सेकेंड क्वेश्चन की जो अपन ने इक्वेशन लिखी ना 30x माइनस 1.5 एक्स क्यूब इक्वल्स टू 0,
हाँ.
उसमें अपन ने जैसे 3 रूट्स निकाले उसके,
हम्म.
एक तो 0 हो गया और एक पॉजिटिव और नेगेटिव में 4 पॉइंट जो अपन ने आंसर निकाला
4.47.
है.
Yes, yes.
हाँ. इस इक्वेशन को अगर हम कैलकुलेटर में डालें तो उसका आंसर 0.945 आ रहा है. ऐसा क्यों? 0.94559.
रुको रुको रुको. 30 minus 1.5 x cube, right?
यस सर.
कैलकुलेटर का कंप्यूटिंग पावर लिमिटेड है थोड़ा, कभी कभी. बात आपका सही है.
हाँ सर.
बट अगर मैं एक्स स्क्वायर माइनस 20 डाला तो मेरे को बराबर आ रहा है, 4.47 आ रहा है. एक्स स्क्वायर माइनस 20 इक्वल टू 0 डाला, मुझे 4.47 आ रहा है. ठीक है. फिर 1.5 एक्स क्यूब माइनस 30 एक्स 0. शिफ्ट सॉल्व. मुझे 30x माइनस 1.5 एक्स क्यूब डाला तो नहीं आ रहा, लेकिन उल्टा डाला ना 1.5 एक्स क्यूब माइनस 30x, तो मुझे आ रहा है 4.47.
सर इसमें अभी क्या करना है, बाई चांस ऐसे कभी कंफ्यूजन में आ जाए तो
ये देखो,
एग्जाम टाइम.
सबसे पहले किसी कैलकुलेटर पे डिपेंडेंसी कम करो, कम रखो. यहाँ पे देखो, हमने अभी कैलकुलेटर यूज किया, कहाँ पे किया? सबसे लास्ट में किया ना. 30 माइनस 1.5 करके उसमें मैंने एक्स को कॉमन निकाला, उस सब के बाद में सबसे फाइनल वाले एक्सप्रेशन में मैंने इसके लिए गया ना, मैं कैलकुलेटर के लिए गया. मैं आई जनरली प्रेफर टू यूज कैलकुलेटर लेस.
ओके सर.
अगर मुझसे जितना मुझसे हो सकता है, मैं खुद का मेरा कंप्यूटिंग जो है माइंड से मैं करता हूँ, माइंड से कैलकुलेशन करके रखता हूँ. ओके, ये रेंज एटलीस्ट आई एम एक्चुअली आई ट्राई व्हाट आई एक्चुअली ट्राई टू डू इज दैट ओके द वैल्यू शुड बी इन दिस रेंज. तो वह उसके बाद में अगर कैल्शियम में, क्योंकि कभी कभी क्या होता है कैल्शियम में, मैंने एक डेसिमल पॉइंट अगर मैंने नहीं डाला, नहीं तो गलत डाल दिया, तो आंसर कहाँ जाएगा हम लोग बोल नहीं सकते. बहुत डिफरेंस आएगा आंसर में. ओके. So for that, if I'm actually already doing it in my mind and I'm getting okay, the value should be in this range. So then मुझे वैल्यू जो है, अगर कैलकुलेटर ने भी गलत बोला, नहीं तो मेरे को रेंज कहीं और कैलकुलेटर में है, तो मुझे पता है कि ओके वो वैल्यू वो रेंज में नहीं है. No, that is not just the case about online lectures. Okay, even during our class lectures also, I try to do that. My mathematics is quite on the good side. स्कूल के टाइम में सब टेबल्स, जो मैथमेटिकल अपना टेबल सब जो होता है, थोड़ा अच्छे से
यस
देखा
सर.
था. तो फॉर मी इट्स इजियर, फॉर मी इट्स लाइक नॉट क्वाइट टफ अ प्रॉब्लम. अभी डेसिमल आपको डेसिमल प्लेस में छोड़ डेसिमल प्लेस तक का छोड़ दो, बट इफ आई एम एबल टू लाइक ओके फाइन द वैल्यू शुड बी इन बिटवीन से 2 and 4, तो मुझे 2 और 2.2 भी आया तो भी ठीक है, मेरे को 2.8 आया ठीक है, 3.5 आया 3.8 आया ओके, बट इफ द वैल्यू इज गोइंग से लाइक सम 7 point something, then I know that yeah that is wrong. Value should be coming in between 2 and 4, and वैल्यू में अगर मेरे को 7 आया तो मुझे पता है कि हाँ कहीं तो गलत है. Okay, so that actually is an automatic check. Okay, so we'll do one thing. We'll stop here for today. Okay, and we'll continue with we'll take our curvilinear motion. Okay, in the next session. Okay, we'll start with curvilinear motion in the next session. आज अभी ऑलरेडी आपको 2 घंटा ये हो गया है, 2 घंटा हमने प्रैक्टिकल होगा, अभी 1 घंटा अभी लेक्चर हो गया. ओके, सो विल स्टॉप हियर. ऑल ऑफ यू क्विकली गिव योर अटेंडेंस इन द चैट बॉक्स. And if you have any questions, okay, so you are free to ask. कभी भी ऐसे ये मत सोचो कि अरे सर क्या सोचेंगे, ये मत सोचो. यहाँ पे आपका अंडरस्टैंडिंग इम्पोर्टेंट है. एंड राइट नाउ वी आर ऑन अ वेरी स्ट्रिक्ट टाइम शेड्यूल. अपने पास बहुत ज़्यादा टाइम नहीं है. ठीक है, तो अगर क्वेश्चन है तो प्लीज डायरेक्ट देम, माइंड में मत रखो. And if you have given the attendance, you can leave the meeting.
सर वो आपने क्या इंसर्ट करने पर 4 पॉइंट आ रहा था कॉमन लेने के बाद ही?
नहीं, मैंने क्या किया, आपने 30x माइनस 1.5 x क्यूब डाला रहेगा ना, मैंने उसको
Yes, sir.
मैंने क्या किया, वो एक माइनस कॉमन लिया, 1.5 x क्यूब माइनस 30x डाला.
अच्छा,
हाँ, तो मुझे 4.47 आया.
ओके सर.
हाँ,
सर
हाँ,
सर आपको दिख रहा है इस पे मेरा वो आपने जो बोला वो टाइप करने पर भी 0.94 ही आ रहा है.
शिफ्ट सॉल्व किया,
हाँ शिफ्ट सही.
एक बार फिर से करो.
ओके सर. सर
स्ट्रेंज, यहाँ पे तो आपको डिग्री रेडियंस का केस तो नहीं देखना है. एक काम करो, एक बार जरा शिफ्ट रिसेट मार, शिफ्ट
ओके सर.
प्लस आर, शिफ्ट प्लस 9, सॉरी शिफ्ट प्लस
यस
9,
सर.
एक बार रीसेट मार के देख. इंटरेस्टिंग, बिकॉज मुझे तो ठीक से आ रहा है. देखो,
कोई नहीं सर, मैं फिर से चेक करता हूँ एक बार.
नहीं एक्सप्रेशन तो आपने ठीक टाइप किया है ठीक ठाक से. ये देखो,
हाँ सर.
द सेम एक्सप्रेशन आई आल्सो टाइप्ड. स्ट्रेंज.
सर ये
इफ इट
x
वर
x इक्वल्स टू l माइनस आर क्या है?
नहीं, एल माइनस आर वो छोड़ दो.
अच्छा
अरे मैंने सारा वाला पार्ट वो छोड़ दिया। ओके सो देखते हैं, आप देखो नहीं तो आप एक काम करो, इफ नॉट देन कीप मोबाइल ऐप, एक जस्ट
यस
एक
सर,
टेस्ट के लिए ना, कभी कभी ना एक मोबाइल ऐप अच्छा रहता है। एंड या आई विल शो यू दैट। ओके हियर आर एबल टू सी दिस?
यस
मोबाइल
सर,
आपको दिख रहा है? हाँ।
यस
तो
सर।
यहाँ पे ये एक ऐप है, देखो।
ओके सर, इसका ऐप का नाम क्या है सर?
CALCES करके।
ओके।
एंड ऐप का नाम देख लो,
यस सर, यस सर।
CALCES। ओके तो दैट ऑल्सो गिव्स मी गुड, वो भी मुझे ये कैलकुलेटर के उतना ही अच्छा है, इक्वल अच्छा है।
ओके सर।